Welcome to the next episode of Geology, GLG 113, Earth the Instruction Manual, or as I like to say, Adventures in Geology. So this is more of a personal sort of presentation for you. This is episode 1. It's a life in geology. It's sort of things that I've done in geology. So I guess I'm trying to hopefully inspire some of you that might seemingly want to become geologists at some point. And I know that doesn't apply to all of you. So there's going to be very little test material. There will be some out of this, but not much. So anyway, this is me over there on the left-hand side, and that's the Grand Canyon on the right-hand side. So that's looking across the Grand Canyon at the North Rim over there. What we do as geologists is we study a lot of things, including rocks, minerals, and things like that. But what people really don't realize is that most of the things that we study, in fact, in geology, are all centered around time. And so we're actually kind of like time travelers, if you want to think about it that way. So we understand, what happened at the various time periods in the Grand Canyon. And so what kind of fossils you find, all that sort of thing. So it's really kind of nicely laid out for us as an entire story. And we're actually solving the puzzle of trying to figure out what that story is. So that is the Grand Canyon. And the next stop along the way here is planet Earth. So NASA calls this the blue marble, but it's mostly blue, as you see on here, right? And so people, when they talk about geology, they usually start it off by saying, well, it's a study of the Earth, right? And so, well, of course it is. Yeah, that's what it comes from. Geo is our planet. And then ology just means a study of, right? And so most courses start that way. I think of it more as an adventure. I think it's a lot more fun to think about geology as an adventure. It's a way to understand yourself and your place in the world. If you ask me, this should be Adventures in Geology. I already told you that. Art is a fundamental aspect of life. I've always appreciated art. I love art. This is a painting of the Grand Canyon by Thomas Moran. Thomas Moran belonged to a group. They were known as the Hudson School. And so when I first started looking at art, I was always drawn to things that were much more realistic in their appearance. I do love abstract art as well. Modern art's beautiful too, but it has a different sort of conveyance, a different kind of meaning that you put behind it. And so this Hudson River School that was put together, they were paintings that were designed to inspire the world before photography actually had developed. And so, because there were no cameras back when Thomas Moran was painting this in the early 1800s. And so he painted things like this. And so here's in the next slide, you can actually see the Niagara Falls here. And so this is from the Canadian side looking into Horseshoe Falls here. You can see a little bit of a rainbow there from all the mist and everything that's at the bottom of the falls there. Niagara Falls is where the Niagara River crosses an escarpment, so it's all based on geology. So many of the original art pieces are based on geology as well. And so some of the coolest places, as you probably already know, are geologic features. So canyons, mountains, waterfalls, craters, volcanoes, geysers, glaciers, caves, islands, and reefs they have a geologic story behind them. And there's a reason why they're there. And so that's what we kind of like to study, in fact. And this is Frederick Edwin Church here, who is a member of that school. It wasn't a formal school, but just people who painted in that style. They call it the Hudson River style, even though this is the Niagara River right here, and Niagara Falls and Horseshoe Falls. So United States is on the opposite shore over there. So that's Goat Island over there that you can see off to the left side of this painting here. Sebastian Pether was also a member of this school, and he actually traveled abroad. I think he was actually French, come to think of it. I'm not sure exactly what his nationality was, but there were a lot of people painting geologic features back in the early 1800s. And so this is Mount Vesuvius here. So Mount Vesuvius was erupting. It had erupted several times, in fact, in between 1819 and 1830. But this eruption right here is when he actually painted, and that was in 1825. Now, the last time that Vesuvius erupted was in 1944, right at the very end of World War II, in fact. And so Vesuvius, it was photographed from I think it was B-17 bombers. They actually took photographs outside of the cockpit where you could actually see the massive smoke and ash clouds coming out of Vesuvius during World War II. and the fighting was still going on. It didn't stop the fighting, but that was World War II. Today, it hasn't gone off for quite a while. However, Mount Etna is going off right now, and that is on Sicily, which is just off the coast of the most of the Italian peninsula there. And so the boot, if you want to call it that. Sicily is actually part of the African continent, and so it's a part of the African plate, in fact. So, but going off because of subduction, in fact, and so that's the process that leads to volcanic eruptions here. So that is Vesuvius right there. The next slide here is from South America, and this is another one by Frederick Edwin Church here, and again, in this same sort of style of the Hudson River School. And so the coolest places always involve geology in some way. This is Cotopaxi. It's interesting. There's a lot of little factoids you learn as a geologist, for instance. You might think that Everest is the highest mountain on Earth, which technically it is in elevation above sea level. But in fact, there's one mountain, if you took the center of the Earth as the place where you measure how distant the top of a mountain is. Well, there's one mountain that's actually on the equator. And because it's on the equator, it actually is higher slightly than even Everest now. It's a Chimborazo. And so Cotopaxi is not, but Chimborazo is one of the highest places on Earth from the center of the Earth out to the top of the mountain there. That's because there's a bulge in the Earth, in fact. So the Earth is an oblate spheroid, and so there's a tiny bulge around the middle of the Earth, in fact. So Chimborazo, you can look it up on Wikipedia if you don't believe me, but that's it right there. So, and I always like to, well, if I like art and put it in lectures, you know that I love art, and then I actually want to participate in it. And I did for a short period of time, but I don't paint anymore. These days, I'm more of a photographer than I am a painter, but these are a couple paintings that I did back in the early 90s here. They're in the collection, actually, of Dr. Steve Rowland, who's he's now emeritus and retired from the University of Nevada, Las Vegas. And so... And in fact, even though I did sell these paintings to him because I really needed the money at the time. I was a graduate student still. And so this is an Anomalocaris rising over here on the left-hand side. So I was painting things from the Cambrian time period, in fact. And so the second one there shows a trilobite being chased by Anomalocaris there, and that's called the chase. While I was never any sort of good in art, I did like painting underwater scenes just because they're, I don't know, they inspire the imagination, I guess, a little bit. So when Steve Rowland bought these things, he actually was confronted by not confronted so much, but some people came into his office one time to talk to him about some ideas about the Cambrian and so forth. I think it was the Great Unconformity that inspired a movie. And the movie was called Unconformity, and so in that movie, they actually have one of these paintings in that movie. I think it was the Anomalocaris rising there. I don't think it was the chase. But one of those paintings showed up in that movie, which made me feel kind of good, get to share things a little bit that way. But, I didn't come naturally to geology. It wasn't something that just entered my mind that I really wanted to do. This is a photograph from me from 1978. I graduated from high school in 1976 from Hillcrest High School in Springfield, Missouri. And my dad was with the U.S. Geological Survey. So you'd think he was a geologist, but he wasn't. He was actually a surveyor or a cartographer and a civil engineer. As a civil engineer, he did a lot of surveying, right? And so that's me back in 1978 after I dropped out of college. Yeah, I dropped out of college. I hope to be an inspiration for those of you who are not sure what you want to do yet. When I dropped out of college, I was actually a pre-law major. I was going to get into law through being a political science major, and so political science was kind of the pathway to become, to get into law school, essentially take the LSAT test and all that sort of thing. But that's me in my old car right there. And in 1978, I didn't know what I was doing, kind of. I had just gotten back from Illinois. I was working at a canning factory after I dropped out of college. I had some bad issues back then. It's like I wanted to, what was the rock and roll and drink and do all of these sort of things. But in fact, that wasn't very good for me. I realized that pretty early on. And so I went up to work with my brother in a canning factory up in Illinois, northern Illinois. And so worked for the Geology Green Giant, in fact. And so, but here is a picture of me after I've returned. My wires had burned out on that Pontiac right there as I was crossing, well, just before I crossed the bridge from East St. Louis into St. Louis, coming back for the holidays in 1978. Well, 77, actually. So this was taken in 78 there. There's my parents' old truck and the old Ford station wagon that we had. And that's my Jeep behind me here. It never did run right, and so I wound up selling it. Taking a huge loss on it, in fact. But I did rebuild the motor in that Pontiac, and here it is after I rebuilt the motor. And I put my way through college. My parents were middle class, and they didn't have a lot of money, and so I worked my way, right? And so first job I had out of high school was I had one job in high school making pizzas up in Michigan before we moved to Missouri. This would be my fourth job, I think, here. Anyway, this will be my fourth job here when I worked for Clark Stations in Springfield. And so I put myself through college by working at gas stations. This is before I went back to college, 1979 here, but that's after I'd rebuilt the motor in that Pontiac there. But just I want to give you the background. It's okay to have to work. It's okay. You can still do it, I guess. It's like I hope that you find that slightly inspirational if you're struggling right now just to make ends meet. So I finally got finished with my geology degree. It took me 10 years to do it, working part-time. I was married at the time, and I had going to night school first, and it kind of sparked an interest. And it's like the next thing you know, I was able to work at nights and still be a manager at a gas station. And eventually I finished up my degree work in geology here at Missouri State University, in fact. Well, you don't know where I'm talking from, but that's where I did my undergraduate degree. It was actually Southwest Missouri State University at that time. And so there's an inspirational quote that I often mention. It's from Winston Churchill, and he gave a speech to one of his old schools at Harrow. Harrow is essentially a prep school for people that want to go on. I think I don't recall if he went to Cambridge or Oxford. I think he went to Cambridge, but I'm not sure. He said, never give in, never give in, never, 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 never in nothing. Great or small, large or petty, never give in except to convictions of honor and good sense. And that's a direct quote from his speech to Harrow. And I didn't give up. It's like I could have stopped when I got here, but I love geology so much that I had to go on. And so I went and applied to the University of Kansas, and I was accepted at the University of Kansas in 1986 to attend school there in that fall. So this is a photograph from one of the things we do in geology is we do field camp, and you do a lot of field mapping and things like that, but that's me on Fred right there. That's the horse in the front. And that is riding on horses around Devil's Tower in the back there. So we were around northeastern Wyoming at that time, and that's a volcanic neck back there. It's a former volcano, would have been formed around that, but that's the remains of that volcano now. That was the summer of 1986. By the time I got to KU, I took my coursework, and I started doing pretty well there. I think, people like me, I guess. I just had an affable personality, and my advisor said, hey, how would you like to go to Antarctica? He had just had a heart attack before I arrived at KU, and I didn't know that. But he was supposed to go to Antarctica, and he's just passed away here in the last year or so here. But anyway, he said, how would you like to go to Antarctica? And it's like, I said, well, I'm married, blah, blah, blah. I turned him down. I have always regretted that. I turned him down the first year. And he asked again, and I said, yes, I'm going. And so these are all the places that I've been in the little red circles in here. So the first year that I went down there was 1989 and 1990. It stretches across into January when they finally pull you out of the deep field. So we went across. So we were so far out in the field that we had to refuel at the South Pole in order to get to where we were going. And so they landed us at the Argentina range the first year. Then they came and picked us up and dropped us in the Neptune range to have the second part of the season there. And so the Argentina range, I think I've got a photograph of that in here, but the Neptune range was one that was interesting enough that we wanted to come back to it at some point. And so I've been there twice to the Neptune range. And then once to the Patuxent range. There was a small twin otter plane that picked us up in the Neptune range and took me and a colleague, Larry McKenna, and I dropped off in the Patuxent range with a small plane, and we skied to the outcrop actually, and had a sledge that we pulled behind us, man-hauled the sledge behind us, camped there for like maybe an hour, a dozen hours, something like that, and then he came back and picked us up and took us back to the regular camp over in the Neptune range. So I've been to the South Pole. That's the refueling station for us, and so. Now, the interesting thing is when you work in the Antarctic, this was part of a National Science Foundation grant that my advisor had. He was a field tectonicist and also a paleontologist. It was a unique combination of skills that he had. Former British officer and so he came to America in the 1960s. He was invited over by a guy named R.C. Moore, Raymond C. Moore. And then R.C. Moore said, hey, why don't you stay here and help run the Treatise of Invertebrate Paleontology? And so he was the editor for that for a number of years before Roger Kaesler finally took over that position. So anyway, I went to the Antarctic with him, and so we wound up landing in Ross Island down here. The third season I was there, we were in the Harold Bird Mountains, and also that's part of Queen Maud Land, they call it there. And so it was really an interesting time in my life. It absolutely changed my life. Here's what they do when you're down there. You have to bundle up all of your gear, and then they drop you off in the deep field with these C-130s. This is actually an HC-130. It's ski equipped, so you can't land on snow with tires, and so they have skis below it. Those skis are about the size of a John boat, essentially. And so the skis land on the snow there. And the snow is much, much harder than you might think. It's called sastrugi. And so sastrugi actually develops like dunes on it and things like that. And so the planes land you out there and they drop you off. We'd already done a fly over the thing and a ski drag, actually. So the ski drag is just to knock down the sastrugi and things like that. They try to find a fairly flat place to land. But this is when we were landing. I think this one was in the Argentina range here in 05. That was the plane number there. So the U.S. Navy flies the planes. The National Science Foundation owns the planes. And so they take the science teams out into the field. And I think the year that we were doing this, where we were Sierra 089, I think it was. But anyway, that is our plane dropping us off. Actually, this one's coming in to pick us up here. And so I'm pretty sure that was in the Argentina range there. When we were in the Argentina range, we found things like these archaeocyasts. You see that thing that's right at the end of the scale there, that's kind of round and half of it's filled with a white substance there. That's actually a carbonate cement, and there's sediment below it there, and then the actual skeletal structure is preserved around that. Today, they didn't know what archaeocyasts were back at that time, but they were actually pieces of a sponge, essentially. And so today we know them as sphinctozoan sponges, but these things were around back in Cambrian time. So this is in the lower Cambrian here, and we were studying the ages and the fauna of some of the rocks in the Argentina range. In fact, that's all that's exposed there, except for the morainal material. That is the material that was moved by glaciers, and a lot of that's probably pre-Cambrian in age, but this is lower Cambrian right here. Here's one of the places right here where we actually got to see a reef. This is Lisignoli Bluff. We collected all sorts of trilobites here. And the reef itself is about 200 meters thick here. It was absolutely enormously thick. The folks that were with me this year was Peter Braddock, who was from New Zealand. He was a mountaineer. And then also Bert, of course, Bert Rao, who was my advisor at the time, and Peg Reese, who sadly passed away last year. She was a provost and also, she held several positions there, but she was at the University of Las Vegas. I was actually her sabbatical replacement back in 1991 and 1992 there. So this is Lizignoli Bluff. It was visited by folks who named many of these spots out here, and so it's and you have a kind of a dearth of like names in the Antarctic, so you have to name them. Everything's named after people. In fact, even my advisor has a mountain named after him. But anyway, this is one of the early places that I got to go in Antarctica here in 1989. There's Peg Reese right here, actually, right next to what they call a wind scoop, and so the winds are notoriously fast. They're rapid. They're high winds there. Let me put it that way. We were penned one time in the Harold Bird Mountains for 5 days, where you could hardly get outside of the tent, and the tent was just shaking. There was so much wind. We were in the middle of a katabatic breeze there, essentially. You could call it a breeze, but it was shaking the tent. So, if you're trapped in the tent for 5 days, you get a little stir crazy, and so you're always brewing up coffee or tea or something like that, hot chocolate, or making something to eat and everything, and reading a lot. This is the only thing that we had back then. I think Walkmans were around back in 1989, early 90s and everything, but that was about it. So anyway, we study all sorts of things, and so you can actually see the glacial ice over there with different years represented by the blue ice, and then also the layers of dust and things like that would have been trapped in the ice. And so this was coming over the range, actually. So downrange from the Argentina range would be off to the left here. And this was a slide I took back at that time. We didn't have digital cameras back then either. So we also, flew over the Neptune Range, and so this is a photograph of the Neptune Range, just to give you an idea of scale here. So that range those are probably about 3 or 4 miles long, each one of those fingers, essentially, of bedrock. And so people wonder, is like, well, what do you look at for rock in Antarctica? It's like, well, there's about 2% of the continent that is actually exposed, and you can see all of the strata there, right? And so we go in, we describe the strata and see what we find there. And so this was actually looking at Middle Cambrian rocks when we were here, and it became part of my master's. I think I had just finished my master's when I went here the first time. And so, but this was actually part of my doctoral dissertation here, some of the rocks from the Nelson limestone that crops out in the Neptune Range here. I finally got the last bits published on the Nelson back in 2017 when we visited the Patuxent Range back in 1992. I knew I had to wrap that up some way, and so we got one more publication out of this sort of field area. Here's what a camp looks like after you unload all of your stuff out of the back of a plane and you haul it up to these hinterland sort of areas. That's Mount Dover in the right-hand side there. You set up camp, and so you build a latrine, essentially. At the time, they didn't worry so much about taking human waste out of these places, and so we built a latrine. And then you would also build a freezer. And so, what do you eat when you're in the Antarctic? Well, you have a lot of frozen food. And it's easy to keep it frozen because they have these tri-thickness and actually plastic-coated boxes, essentially, that you would keep the food in. We also had things like spaghetti and things that, rice always keeps easily that way. But the meat and, any fish, vegetables, things like that, you'd have to have frozen vegetables in order to subsist out here. And, of course, a lot of, fruit, nuts, candy bars, things like that, everything you can to try to keep warm here. So what you see there is, I think that's Peg, actually, underneath on the left-hand side, and that's Bert just next to her there. Everything has to have flags in it because you never know when you're going to get into whiteout conditions. And if you wander out away in a whiteout condition and you don't know which direction you went to go to do something, and you try to make your way back, you could get lost in a real hurry. And if you're in a whiteout conditions, that usually means the wind's blowing a lot at that time as well. And so they're very hazardous sort of conditions. There's 1,000,001 ways to die in Antarctica. And top among those, in fact, would be a plane crash. And so here you are, you can actually see what a camp looks like. Those things are called Scott tents, the yellow pyramids that you see here. So they have a footprint of about 12 feet by 12 feet, and they're about 7 feet high in the middle part there. They give us a radio to communicate with whatever station we can get a hold of. Normally, I think this was like during one of the peak sunspot cycles, and so we were having a heck of a time trying to get communications back in 1990. And so this was it was interesting. We had the sledges that we pulled behind, so you can kind of see the envelope that's around that sledge. Well, that's where we keep rock boxes and all the supplies that we would need to haul away from the landing spot up to the remote camps that we would have. So we'd always go back to the pickup spot would be where they dropped us off essentially. But this is one of the more remote camps that we went to here at Mount Dover. There's just some beautiful sort of rocks there. So this is a Middle Cambrian volcanic rock here on the Neptune Range. Peak doesn't have a name, but it's one that my advisor was suggesting I should be named after me. I'd done a sketch of this in my notes, but it has columnar jointing in it, and so you can actually see some columnar joining when you're a little bit closer than this if you look with binoculars and things like that. And so it's a volcano that went off back during Middle Cambrian time. And so that explosion of that volcano, in fact, destroyed much of the carbonate platform that had developed over this area. So there's a complex history of geology in Antarctica, and there's always things to study there. It's always very interesting to see what you can do. So some of the rocks that were disturbed here, in fact, that's on the Schmidt Hills. That's me when I was leaning against this. You can see a block of material that was blasted out from that volcano up at my left hand there. And then on the right-hand side, that's a different time that we were there. And I think that one was that one's from Supporting Party Mountain. In the Queen Maud Mountains, there's actually one of the ranges there is known as the Harold Burr Mountains. And so this is so that is Larry McKenna on the left-hand side there, and that's Burt Rowell, who's in the middle part there, and then Glenn Ruckhouse, who was our mountaineer that year in 1991. So we had gone there. This was kind of like the middle year, the middle of the 3 seasons that I was there. So what they do is they kick you out for 10 weeks and say, we'll pick you up in 10 weeks, except you have to have radio communications and all sorts of things in between, right? So we would make calls, and we'd either get to Bird Station, which is over on the peninsula, or we'd get Ice Stream B for our comms every day, and they would relay. It's like, okay, 4 souls on board and all is well. That was for, we have our call sign Sierra 089. And later we became Sierra 071, so they can reassign the numbers and everything. But once you get assigned a number, it's kind of nice you got an identity that goes along with it. Here's in the Harold Burr Mountains in the next slide here, and you can actually see Glenn sitting there just admiring the view. To be in Antarctica is just spectacular. This is why it's so life-changing, right? Because it's like, and I know Larry had experienced the same sort of thing, because he would gush about oh yeah, man, it's just, but it's like it's something you do, right? And so, okay, here's one of the places where we got to land. It's the same party that we're in. This would have been Sierra 071 here. That's Larry on the left, Glenn is the second there, and I'm the third one there, and then that's Bird on the right. And so I am standing actually directly over the South Pole there. And so that's the American flag flying over this. The Americans have a base in Antarctica, and you can't see it from this direction, but there's actually a string of markers that show how the ice has moved over the South Pole. So they have to survey it in every year because the ice is constantly moving. It's a giant glacier. So you're standing on a glacier that's about 3 miles thick here. And so it's the geographic South Pole there, not the magnetic South Pole. So there's a huge base. It's back when they used to have what they called the dome. Essentially, there was the Scott Amundsen base at the South Pole. And so they named it after the 2 explorers who first discovered the South Pole. Amundsen was the first there, and Scott immediately after him. And Scott lost his life on the way back. You're going to hear about this when we talk about plate tectonics. I'm going to give you a little bit of background on all the continents, and so we're going to talk about Antarctica in that presentation. Okay, after I left Antarctica, it was another several years. I still work out here. I love the West. So the same thing that draws you to a place like Antarctica, the wilderness, the adventure of it all, can draw people out to the west as well. And so this is looking along Interstate 70, looking from, I think that's the Coal Cliffs in the far distance back there. So this is just after you pass over the San Rafael Swell, which was a little bit west from Green River, Utah. It's still undeformed rocks in here, relatively flat-lying rocks, and you can see the different layers. And so these are all sort of Triassic, maybe some Permian age rock. I think it's mostly Triassic and Jurassic age rocks in this vicinity. When you get over to the far distance, those mountains in the back there belong to the Cretaceous time period. And so really amazing geology out west. And so I got to spend some time out west doing geology. And the kind of rocks that I would look at would look like this. So that is a tidal rhythm. It's a record of how the Earth and Moon relationship actually affected sedimentation back during Cambrian time, about 550 million years ago. And so this is or 530 million years ago. This is a series of laminae that are associated with high tides and low tides. Well, the thicker they are, the higher the tide was at that time. And so it's kind of fun to be able to go out, describe these rocks, and try to describe what happened. There's a tectonic story, there's a sedimentary record, there's an isotopic record as well. Folks who came along after me have described what they call the spice event in these sort of age rocks. This would be pretty close to the beginning of the spice event here on the lower part of what's known as in this case, the Steamboat Pass Shale here. So here's some rocks that are up at the top of that spice event here. And so this is what they call the Barton Canyon, member of the Windfall Formation here. And so the last time I was out here was in 2016, and that's one of my graduate students who was working with me at Missouri State, Wes Weichert. And so Wes did his master's thesis on this set of rocks right here. And so you can see that they are all about the same thickness. Each one of those beds is about the same thickness. And so these weren't affected by tide so much, but it was affected by climatic cycles. And so he did a study of those sort of layers that we have in here, and found that, yeah, it sure looks like they're cyclic. So that's kind of cool. He's one of the best students I've ever had. So it was nice to have him be, and to show this area to him here. He should have gone on for a PhD. Hopefully he has by now, but I'm not sure that he has. So when you're up there, you can actually see the Shell Creek Range. And so that's in the Shell Creek Range on the left-hand side there. That's looking south from the Shell Creek Range from these outcrops that we're actually on the left-hand side here. And then other places out west are just spectacular too. So Hercules Glades is this natural kind of gorge. It's not a very deep gorge, but it's deep enough. It's several hundred feet. And they put a highway through it, and there's a river that runs through here as well. So the river cut through these rocks and left that canyon behind, and they decided to put a mountain road through there as well. So that is a little bit north of Ely, Nevada. When you drive through Ely and you head south, you can see the South Egan Range here. And so this is from a place called Shingle Pass, and that's looking through the pine trees. It's just, why'd I put that in there? It's a spectacular landscape. And you're in places that nobody's there. It's like it's wilderness. And it's not technically a wilderness area there, but many of these places are being studied for wilderness areas. That one's not one of them, however. But this is what you see when you're out west. So this is in the northern end of the Wawa Mountains here on the left-hand side. And so you can see the limestone at the bottom of that cliff right there, and then there's shale in between. So that shale's about 600 feet thick or so there. And so you can actually see the limestones are more resistant than the shale is, so it's easy to spot what's a shale and what's not a shale. Well, we go in there and we describe these things, in bed by bed thickness kind of, and make descriptions of it. And so it's a very detailed sort of work, but at the same time we get slices of time essentially. So there's an extinction event at the bottom, and roughly in the middle of that succession, there's another extinction event in there. So we know that that's equal time. So that you can trace that time slice all around the Great Basin, in fact. And so it becomes really, really important, in fact, to try to figure out. So that whole time period for that shale deposition lasted roughly 2 or 2.5 million years. Now, just to show you how remote this is one of the signs that you see when you drive towards the South Egan Range from the last slide there. So this is on Highway 6, driving south there, and it says the next gas is 167 miles. Yeah, you got to take extra gas. You got to take 2 spare tires. You take lots of water, because if you don't have enough water, it'll kill you. Okay, so you have to be prepared. And so I guess the Antarctic kind of prepared me for survival a lot. And I really appreciated having the Antarctic experience to make me more cognizant of what it means to actually survive. So this is south of Ely there. Other places in the Great Basin are just as spectacular. So this is Great Basin National Park here. Both of these slides are. That's the cave. That's Lehman Caves, or Lehman Caverns, I guess. But anyway, I think it's Lehman Caves, actually, they call it. And so there's more than one cave there, but this is one of the unusual places. In that cave, they actually find something called shields. And so shields are not all that common in most places, but you do find them in Virginia, as I understand it, as well. So an unusual kind of karst landscape here, if you will. It's not really heavily karsted, but this is a product of karstification right here. Whenever you get caves, they were slowly etched drip by drip from water that would run through the cave and carry away the dissolved limestone. Limestone's a lot like a pile of sugar, in which it would actually just dissolve and then the ions get carried away. We'll talk more about ions when we get to crystals and minerals and things like that. On the right-hand side, that's one of the older trees here. So they have trees that date back probably about 3,000 years old. One of the oldest trees was actually cut down by a graduate student back in the 1960s. He was counting the rings to try to figure out how old it is. Well, he killed the oldest tree he could find, and found out it was 3,600 years, 3,700 years old, 38 maybe, I think it was. But anyway, yeah, we don't do that as a national park right now. And so that tree, most of it's going to appear to be dead, but in fact it has enough bark on it to actually keep growing, even though most of it appears to be dead. That rock, that tree is as hard as a rock, let me put it that way. So bristlecone pines like that are absolutely ancient. The oldest one that they know of now is in the White Mountains of Southern California, close to Death Valley, in that area in the White Mountains. So there's like 1 or 2 old trees there, and there's still a few old ones here in this part of Great Basin National Park as well. This is in what they call the Snake Range here. So in the Snake Range, there's this mountain right here. This is another interesting sort of aspect here. That is called Wheeler Peak. It has kind of a flat top on it there, you can see. Well, it's pretty narrow, that flat top that's up there. So you can see the length of it there, but the width is only like about 40 feet thick or 40 feet wide. And so when you climb that thing, which I've done in multiple times now, you are climbing that thing. It's what they call a walk-up. It's not all that difficult to get up there, but I don't know that I'd really set out to want to do that again unless I took a little bit of extra time. Just usually set off at 3 o'clock, 4 o'clock in the morning and try to get up there before the storms roll in the afternoon. So Wheeler Peak, it's interesting. It has an elevation of 13,063 feet, and it's the tallest peak in Nevada, but it is not the tallest point, if you can figure that out. It's the tallest peak in Nevada, but not the tallest point. And some of you are probably very clever and you figured out, it's like, well, there must be a peak surrounding Nevada somewhere, and that's actually the case. It's called Boundary Peak, but Boundary Peak's actual summit is in California. And so as you climb Boundary Peak, which I've done before too, as you climb that, you're getting up higher and higher, and you actually surpass the elevation of this peak, the highest peak in Nevada here. That's Wheeler Peak anyway. It's pretty cool. Here is the view from the top here. I got my camera set up where it's taking a time picture, right? So you set the camera up and trigger it, and then you run back to stand next to your buddies here. So that's from back in climbing. I think that was roughly 2004, 5, 6, somewhere in there. Anyway, that's my buddy John next to me there. And Ray is on the left-hand side, and I think that's Tom, who's in the middle between my friends there. So that's me over on the right-hand side there. So that's the valley behind us there is called Spring Valley, and on the opposite side of it, it's called that's the same mountain range that you saw where West Weikert was, and that would be the Shell Creek Range over there. And so the Shell Creek Range they're all run north and south pretty much through here. And in between every one of these mountain ranges, there's a big valley. Today, in that valley, there's a whole bunch of wind farms that's been built there. And so there's so much wind out there, you can generate a lot of electricity. So after I left the University of Kansas, KU, before I'd finished my PhD. And moved to California, and I took a position with the U.S. Geological Survey before I finished that PhD. Anyway, I got to experience California for a short period of time. I was in a relationship at the time that didn't pan out, as it turns out. But in fact, I had a good time out there nonetheless. But here is a picture of Golden Gate Bridge, and you're looking at the Marin Headlands down there on the left-hand side here. And this is looking back from one of the piers that's out here in San Francisco. That's Ghirardelli Square right there that you can see in the foreground there, and I think that's Russian Hill behind it there. But anyway, people love it here. I love it there as well. That's the Maritime Museum over here on the right-hand side. My ex-wife is still out there and doing something out there, I'm sure. I think she's a real estate agent now, but who knows. When I was at the U.S. Geological Survey, I got to do a lot of things, and so I got to go to the Big Island of Hawaii a few times. I went with my ex as well, and so we did projects down there. I worked on Molokai, and this is actually a visit to the Big Island here. It's very desert conditions when you're in the southwestern sides of these islands, and so that's all basalt flows that are across the Big Island here. And so when I finally came to my senses, I guess, and tried to no longer survive on $38,000 a year in the Bay Area, I left and I spent some time meandering a little bit. And here I am on Mount Shasta climbing with my buddy John Kramer, and so I had ridden down there from Oregon, where I was staying at the time with my brother, and rode down on my motorcycle here. That's an '82 Kawasaki Spectre 750 right there, loaded up with all my climbing gear and camping gear, and I rode it down to Mount Shasta, and together we climbed Mount Shasta. Have my crampons and all that sort of thing on here. And they're not on in this photograph, but so the summit's just right behind me in that photograph there. So you dash up, touch the top. You can't even stand on the summit there. It's that narrow, right? So it's just one little spire of rock. So you go up and you touch, okay, here's the top of this mountain, and then you go where it's a little safer to stand. Anyway, I had a blast in my life. I guess you would say it's been a definite adventure. When I left California, I came back to Missouri. This was in 2001 after 9/11. And in fact, this was when there was a lot of activity in the United States and people were trying to sort their lives out. Well, I tried to sort my life out as well. I came back to Missouri with the promise of a job that didn't pan out as well. But when I was coming back, I decided finally to stop at Meteor Crater. And so this became influential in my life. So Meteor Crater, in fact, I got to see it for the first time in 2001. It costs I think it's about $20 now to get in to see the crater, but they have this wonderful museum there. So it's definitely worth the money and the effort to go into Meteor Crater. It's about 15 miles off of one of the main interstates that cuts across the northern part of Arizona there. And so, but anyway, this is in Arizona, close to Winslow, Arizona, in that area. It became influential for me because when I was with the USGS, I learned how to do these sorts of maps. So this is a digital elevation map, and that's from, so I got to discover an impact structure of my own after being inspired and knowing that other people have looked at these sort of things, but they didn't know how to do the mapping and everything, right? And so I did the map that's on the left-hand side here. That's a place called Wabla Structure, and the city of Osceola is up at the north next to that lake, in fact, close to this, and the little town of Vistas at the north end of that crater that you see at the bottom here. And so that's the crater is actually that sort of round feature there, but there's a larger round feature around that we call the tectonic rim these days, and Wablo Creek runs through this area here. So that's what sometimes meteors look like when they strike the Earth. You have to have a pretty big one to do that. And so the estimates on the size of the meteor that hit here was roughly 350 to 400 meters across. It could have been 500 for all we know. We're pretty sure it came out of the southwest. What is today the southwest? It would have come out of the west back during the Mississippian time when this thing actually hit. And so that is Wobblo impact structure on the left-hand side here. On the right-hand side, you see a very muted sort of looking donut shape in the middle of that digital elevation model there, DEM, they call these things. And so I began teaching at Missouri State back in 2002. And so I found this thing in I think October 2002. And so that's Decaturville on the right-hand side. It had already been discovered and described in some detail back in the 1970s. And so, here's a direct comparison. There's actually 3 of these things in Missouri. So there's Wobblo, there's Decaturville, and then there's also Crooked Creek, in fact. So all of these things, in fact, can cause a lot of deformations. Deformation means that rocks can be bent and broken and things like that. And so back in 2009, I was out with a student. We're kayaking on the Truman Reservoir here, and you can actually see a broken fold in this photograph here. Now, the lake water is not the most beautiful in the world, but believe me, there's a lot of crappie and bass and things like that. And so a lot of people that are around here are only fishermen. There's no roads or anything around this feature. And so that's actually been thrusted and then broken. That fold was actually broken right there. And so it left that sort of thing. We call that one knuckles, in fact. So we try to nickname these things so we know what we're talking about. So that is along Truman Reservoir there, and that's a thrust fault and a broken fold there. Here's another one we call the Shepherd's Crook here. And so one of the things when I got back and was finally teaching at this university, at Missouri State University, this is another one here. This is actually, we refer to this one as the Shepherd's Crook here. And so it's bent and folded some of the rocks in here, and you can see how they're kind of twisted a little bit there. So that's Brandon Zaitz, by the way, there, who's with me. And so he was a student back in this time, 2009, 2010. And he's gone on, I think he works for an oil company now, but I'm not exactly sure which oil company it is. Somewhere down in Texas or Oklahoma, I think. So I was teaching now in 2002, 2003, and haven't stopped teaching now, even now that it's 2026. This is, one of the things we get to do in geology is we get to do field trips oftentimes, and so geology students get to see things like this. And so this is actually a photograph taken from the top of Hauling Peak, close to Canfield, Canada here. This is in Alberta. And so you can see Mount Rundle in the distance back there behind this peak that's in the foreground here. And so we take students there in order to see these things. So you look at this landscape and it's like, what's the geology in all of this? Well, it's like there's nothing in here that's not geologic related. So this is the next photograph here. This is the city of Canfield, right? And so you drive up this valley. The Bow River is the river that runs through here. Now, the Bow River actually occupies this sort of U-shaped valley that would have been carved out by a glacier. At one time, that whole valley was full of glacial debris, glacial ice. And so it left debris behind. And so that's what you see on the distance on the opposing range over there below. So you get below tree level, you can see where tree level is, and then you get to the bottom of that steep slope there. That's all glacial till in there. It's actually what they call a lateral moraine. And a lateral moraine is a whole bunch of material that's been pushed down the valley by the glacier. Once it was actually had formed and had moved and carved out this valley and left that debris behind. And so the Bow River actually occupies what is left behind from that glacier disappearing. You have to go all the way up past Banff, quite a ways to the north till you finally get to the Athabasca Glacier. And the Athabasca Glacier still has glacial ice in it, at least for now it does. The glaciers are melting pretty fast up there. And people are concerned about it, of course. You can't turn on the television or radio stations or anything like that these days without hearing about climate change. Well, let me put it this way. Climate change is real, okay? It is. It's actually warming up. And so, it's up to you whether you think that's a bad thing or not, and a lot of people think that it probably is a bad thing because we think a lot of the actual warming today is attributable to the burning of fossil fuels. And so that's why there's been a shift towards alternative fuels that don't use fossil fuels for generating electricity. So we don't like to use coal because coal is a dirty product. We don't like to use natural gas because it too is a fossil fuel. So what else in this is all geology? Well, you can see the rocks in the foreground here. You can see the rocks in the background. But everything in that city has to be built, right? All the roads have to be, all the bridges have to be built. All of those come from the earth. Everything that we have that's a consumer good or any sort of construction material has to come from the earth. The iron, the rebar, the materials, the chrome, anything that you have, anything you can possibly imagine has to come from the earth. We don't get it off the meteorites. We don't get it off of, the moon and other places like that. It's not practical to mine any other place on earth. So mining and the production of fossil fuels is one of the ways that we fuel our modern economy. Hopefully we'll get to switch to, more practical sorts of means of electrical generation at some point, but that remains to be seen. It all depends on politics, doesn't it? And I'm not here to persuade you of politics one way or another, but I am here to tell you that the things that we have today pretty much all rely on natural resources, whether they're energy resources or they're mineral resources. And so both of those things are important to our society as we know it. And so it depends on understanding it, right? This is one of my colleagues. This is my colleague for the field trip that we led up here. There were about a dozen students with it, maybe 14, 15 students. I think it was 16 actually altogether. So we went to Banff and places like that. Banff is actually, he's a geographer. He's not a geologist, but in fact, he was leading the geography part of this. And so there's a hot springs here. So there's a lot of cultural geography in this area. But here I had him posed next to this fold right here. And it's actually a fault, in fact, as well. And so you can kind of see how the beds are twisted here, just like the ones in that meteorite impact, except these are from mountain building processes, not from a meteorite impact here. So that's in Banff in 2008. Among other things, I've had the opportunity to go. He actually teaches at Mid University in Sweden, Mid Universitetet in Östersund in the middle of Sweden. And so when we visited him back in 2008, and my wife and I went over there in 2008 and 2009, I've been over to Norway and Sweden a couple times, 2 times, I think, yeah. Anyway, this is one of the trips that we did through Norway. And if you want to talk about the most beautiful places on earth, let me give you a shorthand list of this thing. Norway is right up there in the top 3, I would say. New Zealand is right up there in the top 3. Scotland is right up there in the top 3. Okay, there's a 4th one too. Wales is up there as well. Now, my wife, who's been to Iceland, says that that's up there as well. So there would be 5 places on earth that you really need to visit. And so I have not been to Iceland yet, but I'll go someday. Hopefully soon. Okay, so anyway, this is a fjord right here. Fjords were carved out by glaciers as well. And so fjords, the glacier's gone now, and seawater came into this fjord. And so that's Sjonenfjorden right here, and really kind of an amazing sort of place. It was in about 2016, the first time that I got to go to Jamaica. One of my colleagues at Missouri State University, Bob Pavlovsky, was another geographer, in fact, but he's more kind of on the geology side. And so he does a lot of things like stream profiles. He does a lot of stream dynamics and things like that, and looks at transport issues and other things with streams. And he was the director of the Ozarks Environmental and Water Resource Institute. And so we went to Jamaica with students again, and so we get to go to a lot of really cool places. In Jamaica, you see things like this, and so in Jamaica, very tropical. That's the Caribbean Sea that you're looking at out there. You're on the kind of on the eastern edge, I guess you would say, of the Nicaraguan rise here. So it happens to be that Jamaica sticks out of the water, but you're actually looking west here. So if you went far enough to the west, probably about 800 or 1,000 miles to the west, you'd wind up in Nicaragua. So this is interesting because Jamaica is really, really active geologically. And so Those things that you see here are not hurricane rocks. Those things are actually in place. It's an ancient rock that's been encrusted by worm tubes. And if you know anything about ocean worms, it's like they live underwater. And so, but these things are exposed above water now. So there was some sort of event that lifted them above the water here. And so that, in fact, is what they call a raised shore platform right here. So tectonism is going on here. So that is, because it's relatively recent tectonism, they call it neotectonics or neotectonism. And so that is a buttonwood tree here in the foreground here. Sorry, I'm losing my voice a little bit here. This is my second lecture for the day. I'm going to try to get one more done before I finish, though. So you might expect a little bit of hoarseness by the time I get done. So anyway, that is a buttonwood tree in the foreground here. It just makes a beautiful photograph here. So anyway, that is in the southwestern part of Jamaica. I think Treasure Beach is one of the places that got hit by this last major hurricane that hit Jamaica. And so that was really a tragic sort of event, and I'm hoping to go back down there. I was hoping to have some funding through my university and through our college, but it doesn't look like that's going to happen right now. So hopefully we'll find a way to get some funding to get back down there and help the people of Jamaica. So that is Jamaica right there. Here's another one on the list here. Jamaica's pretty cool too. Okay. If there's a top 6, Jamaica's in there. This is the Isle of Skye right here. So this is in Scotland right here. You can see the Northwest Highlands in the distance there. That's all those mountains that you see in the background there. And the highest mountain, in fact, is one of those. I think it's the one on the right-hand side there, and that's going to be Ben Nevis. So Ben Nevis is the highest point in Scotland. Now, it's only about 4,000 some feet thick, high, but it's we hiked that, in fact, but after we hiked it, we came out to this area. Isle of Skye is like one of the most spectacular places in Scotland. And so there's a little island that's in the foreground here. That's called Ramsay. Well, actually, it's the one in the distance back there. That's called Ramsay. And so these sort of features that you see here, this is right next to a feature called the Old Man of Storr, which is a vertical pillar of rock, essentially. And around here, this is all volcanic rock for the most part. Now, that rock actually was an intrusion that came into these rocks back when this thing was very active tectonically. Scotland was actually once part of North America, and it split off from North America, and these volcanics are part of that split. We're going to talk about plate tectonics more so even in the oceans lecture, which is going to be the next one I record after this. So I kind of skipped over. I've already done the one on tectonics already. So, but that's the Isle of Skye, amazing sort of place. When I mentioned Wales, this is Wales right here. Wales was once glaciated. That's why it's flat at the top of all these hills you see here. And those hills are about 600 feet high, but you can see how twisted the rocks are here as well. So that was from a collision when this area actually joined with North America and crushed into North America and left these folds behind here. So this is a place called, well, it's along the Pembrokeshire coastline here. So Pembroke is that sort of western tip of southern Wales. And so Pembroke is one of my favorite places on earth as well. There's a few of them in Wales. In fact, I got to spend about 10 weeks in Wales. One of the more exciting times I've ever had in my life. That's where I wrote a paper, in fact. And so it's a good place to write. It's a good place to experience. And so you walk one day and write another day. And then my wife and I went to this area in Nicaragua. And so this is the Playa Maderas here, or Maderas, it actually should be here. So Playa Maderas is on the west coast of Nicaragua, very close to the Costa Rica, the border, in fact. And so we actually flew into Costa Rica, took a taxi into Nicaragua, and then we're here for my wife's niece's wedding here. And so that wedding was back in 2018. And so that is another one of these places that's really pretty spectacular here. Those are volcanic rocks as well. So if you're going to get a load of this, but you're going to see that this is on the Isthmus of Panama. This is a little bit farther north from Panama and north of Costa Rica as well. But these are volcanic rocks. And so there's two major volcanoes in the southern part of Nicaragua, and there's a huge lake right next to them. And so it's one of the few lakes, in fact, freshwater lakes, that actually is host to bull sharks. And so there's a lot of bull sharks apparently in that in that lake, as well as it does have a connection to the sea. There's a river on the other side, on the Mosquito Coast, where the sharks could actually get up through the streams to get into the lake that way. Anyway, this is in Nicaragua. One of the places that I got to go recently here was New Zealand, and so this is in Milford Sound right here. It was a very rainy time when we were there, and so here you can see the clouds are just breaking up on the right-hand side. We had done a boat tour, and this is another one of these glacial valleys that was carved out. So there are not only fjords in Norway, there are also fjords in the southwestern part of the South Island of New Zealand as well. And because of the steep, incline there and all of the rain that they get in this area, this is one of the wettest places on Earth. There's waterfalls everywhere. So again, geology is driving all of this. So those are mostly glacial sediments in the right-hand side here. You can't see the sediments, but in fact, you'll see some in another presentation, I think, here. But anyway, that is the fjordlands of Milford Sound. If you went to the north end of the South Island, you would wind up in a place that's really tropical. And so this is Abel Tasman Park here in the north end of the South Island here. And so we did a hike through Abel Tasman Park, about 8 or 10 miles, something like that. And you can see beautiful beaches, beautiful, that sort of emerald green water here. Some of it's blue as well. And then so finally, we actually took a ferry across from the South Island to the North Island. We drove the entire island in the course of 20 days. And this is in the North Island here. And this lake that you see here, that's Lake Taupo. Lake Taupo is regarded as a super volcano. It erupted, I forget how many, like 5,000 years ago, something like that, they think it erupted. And so those are little tiny volcanoes that were resurgent in the middle of this larger volcano. So the volcano, the actual rim on the opposite side is where the mountains are in the far distance back there. That's about 15, 20 miles across there. Really a kind of amazing place. So yeah, I was on sabbatical last year about this time, and so the other place I wanted to go, in fact, you've seen this before in the first lecture, the episode 00. In fact, this is in Brussels right here. You haven't seen this photograph, but this one's from the capital of Belgium here, or Belgique, as they say in French language. So Belgium and Belgique are the same, and so this is part of their capital area, and this is called the Grand Place. And so the Grand Place, it dates back to 1500s, 1600s. Many of the buildings in here, in fact, represent trade unions and things like that. The one on the left there is the city hall. The one on the right is some sort of trade union, I think, there. Anyway, this is there were so many people here. It was just this was in March, and so it was really kind of a neat time to visit. It was good for me because there were trees were not in bloom, and the leaves were off and everything, so it was easier for me to make photographs of the geology here. Now, this next slide, you've already seen this one before, but that is in Dinan, which is a little south of Brussels there. The one on the right-hand side, that is called Bayer. It's a Rochers de Bayer, and it is a split rock, essentially, that they decided to put a road through. It's about 3 meters, 3.4 meters across, I think, right there. But anyway, they split the road, so one lane goes around the right-hand side of that photograph, and then the other one comes right through this way. And so they drive on the right-hand side of the road there, so will be oncoming traffic coming this way. So other things that you see there, this is the Rochers de Frères, and so this is it essentially means bear, essentially. And so this is the bare rocks, essentially. And so this is a world-class sort of rock climbing area right in here. Now, I'm past the age of wanting to rock climb much, but in fact, what you see here, in fact, are a whole series of, most of these are not bolted climbs, and so people would actually do a lot of, not so much free climbing, but they would do, they'd set their own protection in these sort of climbs, I think. There may have been some bolted climbs there, I'm not sure. But that's the Merce River over here on the left-hand side, and so this pathway actually winds around the rock outcrop there. So I was studying the limestones there during my studies for sabbatical, and so I'm still working on some of the papers that are going to come out of that. In Arkansas, You see the same sort of age rocks. And so those are the same age rocks right here. Over on the left-hand side, you can see Big Bluff. If you've never been there, you really owe it to yourself. You have to be careful when you go there because it's a very precipitous drop. If you get on the goat trail there, and so you can actually walk around this bluff about 300 feet up above the river. That's the Buffalo River at the bottom of that area there. And on the right-hand side, actually, that's called Eden Falls over there, and that's in Lost Valley State Park. And so that, I've already shown you a photograph of one of the natural tunnels there when we were talking about what is science. In this case, that's Cobb Cave right there, and in Cobb Cave, you actually get a lot of Native American artifacts and things like that have been found there. It's off limits, actually, to collect there. It's a state park, among other things, but in fact, this would have been like a small a gathering. It would have been like a little village of folks who were living in this thing back during Native American times and before the Europeans landed in this area. So this is the cool thing about being in geology, for me anyway, these days. I love teaching, and I love giving and showing people what's going on in various things, right? So in this case, these are students. We went to Florida back in 2005 and 2008, and so this was the group from 2008. And so there's a whole bunch of people here that you really bond with when you go on these field trips. So almost all of those folks were geology majors. I think all of them were, in fact. And some of them are in industry now. Some of them run their own companies, in fact. And so some of them work in St. Louis, actually, and some of them work for the State Survey. So there's a whole group of people in here that are just spectacular folks that you get to meet. For me, I'm a geology professor now, so it's another step up, in fact. And so anyway, that's the Florida Keys in 2008. On the right-hand side, that's when we did the trip to, we actually flew into Seattle, drove into Vancouver, Washington, spent a few days in Vancouver, and then headed east from there and went to Kananaskis, where we stayed at a camp there that's run by the University of Alberta, I think it is. And so Kananaskis is where we stayed at that trip. But these are a bunch of my friends here. There's Dimitri and Evie there on the left-hand side, and then a whole bunch of students. And I still see some of these students from time to time. That's Tori back there on the left-hand side there. And so this is a whole group of people that you get to make friends with. And so that's the nice thing. So you can travel all around the world and have these adventures, but adventures are, as you probably realize by now already, are always best when they're shared. Anyway, thanks for your indulgence. I just wanted to tell you a little bit about me. So yeah, I worked gas stations and Burger King, and I still am friends with people I worked with at Burger King, which I really dearly love, having friends for over 50 years now. 50 years this year, in fact. And so this is the sort of life that I've led. And geology, going to grad school and becoming a professor has allowed me to do probably one of the best jobs that I've ever had in my entire life. Now, I've done some other things in addition to this, but I worked for a couple of oil companies in summers, right? And so I worked for Mobil 2 summers, and then I worked for Shell 1 summer. And so that was in 87 and 91 and 93, in fact. And so I got to fly around in helicopters all one summer for 5 weeks, in fact, in not continuous flying, but to fly us up to a place and do the stratigraphy there and then tell people like what we saw there. There's really a lot of fun in geology, I guess is what I would say. Make the most of your life. That's my advice to you. Make the most of your life. For all we know, this is the one that you get. And so do your best. Anyway, I will see you. You're going to hear about the plate tectonics next, and then we're going to talk about oceans. Much of plate tectonics actually occurs in the ocean. So with the oceans presentation has a little bit to do with salinity, but it also is going to have to do with subduction zones, spreading centers, things like that. Anyway, I will talk to you on the flip side here. So cheers, and I will see you very soon here. So this is one last parting shot. This is from a sea cave. Or flank cave, they call them in this sort of parlance of karst topography here. That is the Caribbean that you see out there in the distance. So you can actually kayak into this cave. This is from Bluefields Bay, another place where I've got a lot of friends that I really miss and want to get back down there and start studying some more of the rocks down there and help the people out that are in Jamaica these days. They need the help. So anyway, cheers, and I will talk to you soon. Bye for now.